Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we will be having a look at binomial expansion. So without wasting any time, let us begin. So we are having a look at binomial expansion, but what exactly is binomial expansion? We all know that if I were to give you something like 3 minus x all squared and you were asked to expand this, it's most of you would say it's not really that hard of a deal. All you have to do is just rewrite this as something like this: 3 minus x, 3 minus x, and then expand. So this becomes 9 minus 6x plus x squared. Right, if I said we had something like 3 minus x all cubed, now this might take a bit longer, but eventually you would also get to the right answer. But what if I told you we have something like this: 3 minus x to the power of 8. Now what mathematicians saw was that writing 3 minus x 8 times like this, 3 minus x, 3 minus x, 3 minus x till 8 times, is a waste of time, and it will take a lot of algebra and lots of collecting of like terms, and it will waste a lot of time. Really, that's the thing, time. So they came up with something called binomial expansion, which uses a certain formula to help expand brackets or terms that are to a very significantly high power, such as in this example 8. So if I was to apply that formula, the formula goes something like this. Suppose we have a plus bx all to power n, where n is a very high power, let's say 4 and above, where a is a constant and b is the coefficient of x. So if I was to expand this, the general formula we use is n combination r multiplied by a to power n minus r multiplied by bx all to power r. And this is done for each term that you want to expand to. So suppose this is just for all the terms having the coefficient of x. If you want to do it for coefficient of x squared, you would apply this formula again and add the next part. But what exactly is the C over here, the combination? From your calculator, if you press shift and the division sign, you get combination. So for example, if I was to write, let's put in our calculators 9 combination 3, that gives us 84. And one thing to note is that whenever you are using combination, the number that comes first cannot be greater than the one that comes second. So 9 combination 3 can work, but 3 combination 9 cannot work. It will give you math error. Now this is a topic that's obviously better understood if you do examples. So let's go right ahead and dive into our first example. Okay, so the first question asks us to find the first 3 terms in the expansion in the ascending powers of x of 1 minus 2x all raised to power 5, and this goes for 2 marks. So to begin with, we can just write 1 minus 2x raised to power 5. Now the formula I gave over here, in most scenarios, just writing out this formula does not get you a mark. So lots of mark schemes, depending on your exam board really, but a lot of mark schemes do not really show this step. They'd right ahead go in and plug in the values. So that's what we're going to try and do as well, because we're not going to get a mark for writing that formula down. Now it says find the first three terms in the expansion of 1 minus 2x all raised to the power 5 in ascending powers, obviously. First step is always to write down 5 combination 0. Always starts with 5 combination 0. Sorry, not 5, n combination 0, just that in this case our n is 5. But always start with n combination 0. And as our formula suggests, the next thing we do is that we multiply that by one of the terms inside, most likely the term that's independent of x, and in this case it is, so we multiply it and take that to the power of n minus r. So in this case this would now just simply be 1 to power 5, because our n is 5 and our r is 0, and 5 minus 0 is still 5, multiplied by minus 2x raised to power 0, plus, because it said find the first 3 terms, so we do this 3 times. We've done it once already. This is the first one. All of this is 1. Now we do it 2 more times, but with different values. So now we would have plus 5 combination 1. So you can see the combination, the number that comes after the combination is gradually increasing. All of this into the power of 1 to the power of 4, because we do n minus 1. Our n is still 5, but our r is 1 here, so it becomes n minus 1. So it's n minus r, and our r is 1, so it becomes n minus 5 minus 1, which is 4. And multiply this with minus 2x raised to power r. Our r is 1, so all of this raised to power 1. One trick that helps a lot of students is that the power of the second term over here, so the power of this guy over here, is always going to be the same as your r, which is this over here. These two are always going to be the same, no matter what term you're expanding this to. And then the next one would be 5 combination 2 into 1 to power 3. 5 minus 2 is 3, into minus 2x raised to power 2. Again, this guy and this guy are still the same. Now we can go ahead and plug these values in our calculator. So doing the first part here, 5 combination 0 is 1, times 1 to the power 5 is still 1, and minus 2x to the power 0 is 1 as well. So all of this gives us 1, plus 5 combination 1 times minus 2x. So that's 5. 5 combination 1 is 5, times 1 is 1, times minus 2x. This gives us a total of minus 10x. So this becomes 1 minus 10x. And then the third term rather, 5 combination 2, if I'm not wrong, is 10. So you have 10 times 1 times minus 2x squared. So this becomes minus 2x times minus 2x, which is 4x squared. And doing this is plus 40x squared. And the question asks us to find the first 3 terms in ascending order, and this is the ascending order. Always good to just leave 3 dots here. This shows that this can be expanded to even further terms. It's just that the question asked us to sorry, this is squared, 40x squared. Yeah, it's always good to write these 3 dots down, because it just shows that this term can be expanded to even further powers of x. It's just that the question asks us to find the first 3. Now that's for the I part. Now for the II part, it says rather that given that the coefficient of x squared in the expansion of 1 plus ax plus 2x squared and 1 minus 2x to the power 5 is 12, find the value of the constant a. So they're telling me that if I multiply 1 plus ax plus 2x squared with 1 minus 2x all raised to the power of 5, if I multiply them out, my coefficient of x squared is going to be 12. So tell me that the coefficient of x squared is going to be 12. Now you might wonder that they're asking us to multiply them out, so we take all of this, expand it to the power of 5. No, there's no need. In part I, we were asked to find the first three terms of this very expansion, which we got as 1 minus 10x plus 40x squared. So if I just go ahead and do 1 plus ax plus 2x squared into 1 minus 10x plus 40x squared, and then I can just simply find the two or three multiplicable terms that give me the coefficient of x squared. Now that might sound a bit complicated at first, but what that really means is that when you have a situation like this, where you have two brackets, when you have two pairs of brackets with terms in them being multiplied out to give you a coefficient of a certain power of x, all you do is you look at the coefficients on either side of the brackets and see which one will multiply with which one to give you something x squared. For example, if I multiply my 1 with the minus 10x over here, I'm going to get minus 10x. But I don't need that because they told me that the coefficient of x squared is 12. And what I just did is giving me minus 10x. So I don't need x. If I do 1 times 1, again, I'm not getting an x. I'm getting a term independent of x, which I don't need again. However, if I do 1 times 40x squared, I'm getting 40x squared, and that is something I do need because I want anything with a coefficient of x squared, because that's what we're trying to find. Now that's not the only one that's present here. If I go ahead and do ax times minus 10x, I get minus 10ax squared, because x is here and x is here and they multiply and become x squared. If I go ahead and do 2x squared times 1, I get plus 2x squared. And these three are the only these are the only combinations that would give me x squared in my answer. So all of this, you can then equate this to 12x squared, because the total coefficient of x squared is 12. Now from here, you don't need to solve. All you can do is just factorize your x squared out on the left hand side. So you have x squared into 40 minus 10a plus 2 equals to 12x squared. X squared and x squared cancel. You have 42 minus 10a equals 12. You have minus 10a equals to 12 minus 42, that's minus 30. And then you have a to be 3. Minus 30 divided by minus 10 is 3. Again, for this part here, you just multiply each term on the left bracket with the one on the right bracket. That would give you the coefficients of x squared, anything to the power of x squared, because that's what you're trying to find. And the way I did it are the only ways you can get anything to power with a power of x to 2. Suppose I did the ax over here with, let's say, 40x squared over here, I wouldn't get x squared, I would get x cubed. Hence, that's why I did not use it. And when you do that, you simply add them all together over here, like I did, equate it to the x squared and the coefficient they gave, which was 12. Factorize x squared on both left side and right side, and then you can easily solve for a. That was the first one. Now let's move on to the next one. The next question says, part I, find the coefficients of x squared and x cubed in the expansion of 1 minus 2x all to the power 7. 1 minus 2x all to the power 7, and I'm wanting to find the coefficients of x squared and x cubed. Now I could directly go ahead and find x squared and x cubed, but just for the sake of explaining this topic in detail, let's take it all step by step. To begin with, again, I would do 7 combination 0, always do combination 0 first, into 1 to the power 7, into minus 2x to the power 0, plus 7 combination 1, into 1 to the power 6, into minus 2x to the power 1, plus 7 combination 2, into 1 to the power 5, into minus 2x to the power 2, and we would also have plus 7 combination 3 into 1 to the power 4 into minus 2x to the power 3, and I can stop here because I know this power will give me an x cubed because the x is being raised to the power of 3. As you can see, patterns, this guy is always the same as this guy here, 3 and 3, again here as well, 2 and 2, and then obviously the power of 1 is being decreased, so you do n minus r. So like over here we have 7 combination 3, so this becomes 7 minus 3, which gives us 4. So going ahead and do this, all of this gives me 1. 7 combination 1 is 7 times minus 2x, that's minus 14x, so you have 1 minus 14x. The next one, we have 7 combination 2. 7 combination 2 is, if I'm not wrong, 21. Let me just confirm real quick. 7 combination 2, yeah, 21 times 1 times minus 2x squared, that's minus 2x all squared, that's 84. Sorry, my bad, not 84. That's 4 x squared, and then 4 x squared times 21 is what's 84 x squared. So plus 84 x squared, and then the final one, 7 combination 3, that's 35 times minus 8 x cubed, and that is minus 280 x cubed. Now the question asks us to find the coefficients of x squared and x cubed, so we can just disregard this. We have 84x squared minus 280x cubed, and then you can write a final answer as 84 and minus 280, because they're asking you for the coefficients of the two. They don't want x squared and x cubed in the final answer, they just want the coefficients of it, and coefficient does not have any x attached to it. I mean, it does in theory, but the way they're asking the question, they don't want that x attached. So your answers are 84 and minus 280. The next part says, hence find the coefficient of x cubed in the expansion of 2 plus 5x into 1 minus 2x all to the power 7. So again, we're having something like 2 plus 5x into was it 1 minus? Yeah, 1 minus 2x all to the power 7. And because we did expand this to two terms of 84x squared minus 280x cubed, we can just input that here. So 2 plus 5x into 84 rather, 84 x squared minus 280 x cubed, and then we see what can I multiply with what to give me anything with x to the power 3. So if I multiply 5x with 84x squared here, I get 420 x cubed, and if I multiply 2 with minus 280 here, I get minus 560 x cubed, and I can just simply do the subtraction here. So that would be 420 minus 560, which is minus 1. 40 x cubed, and again they were asking us for the coefficient of x cubed in the expansion, so the coefficient is -140. Now one question that may be arising is that how do we know that what we did in part I is the exact same thing that we substitute for part II to be multiplied with? Now if you look at it logically, in most cases it is the same thing, but even if you're not sure, you can look at it logically and think how can it affect the question. For example, we're being asked to find the coefficient of x cubed here, and we were given 2 plus 5x. Now thinking commonly or logically or applying common sense, what are the ways that you can get x cubed if you're multiplying anything with these guys? You can get an x cubed if you're multiplying anything, let's say bx cubed with a constant, you're going to get x cubed. Or if you're multiplying cx squared with something that's 5x, you'll eventually get something cx cubed. If you have anything like, for example, just an x, and you're multiplying it with this, you're going to get 5x squared. And we don't want x squared, we want x cubed. And that's why from this question you can see part I, we did find -14x, but we didn't need it, because the only way for part II that you can get x cubed is if you have an x squared and x cubed in the original part from part I. And that's exactly what the question asked us, for coefficients of x squared and x cubed. So you can think of it logically and just figure out which values of x you need, or which powers of x you need rather. Right, on to the next example. So this one says that it is given that in the expansion of this, the coefficient of x squared is -15. Find the possible values of a. Okay, it's of course the full mark, so there's a bit of working required. We have 4 plus 2x being multiplied by 2 minus ax all raised to the power 5, and it tells me that the coefficient of x squared is -15. Now then, you can see the way this question is kind of direct and straightforward. They didn't ask us to first find the first 2 or 3 terms of this guy, they just put the question together and expects us to do that first. So take this guy out first, 2 minus ax raised to the power 5, and expand this using a binomial expansion. But you would now want to wonder until which term rather. And you can just think of it logically. They're telling us that the coefficient of x squared is -15. So just take this to your second term. Just expand it all the way to the second term. That means x to power 2, not a second term rather, to the power of x squared. So this would now be, you can start this off with 5 combination 0 into 2 to power 5 into minus ax 0 plus 5 combination 1 into 2 to power 4 into minus ax to power 1 plus 5 combination 2 into 2 to power 3 into minus ax all squared. 2 to the power 5 is 32. Then 5 combination 1 is 5. 2 to the power 4 is 16. So 5 times 16 times minus ax. And doing all that, that gives minus 80 ax. And then 5 combination 2 is also, this is 10 rather, so it's 10 times 2 to the power 3, which is 8, into a squared x squared, because it's minus ax all squared, so both of them get squared, and 10 times 8 is 80, so this becomes plus 80, a squared x squared. So now we can go back to our expansion. So we have 4 plus 2x into 32 minus 80ax plus 80a squared x squared. And remember, the question asks us to find the value of a, given that the coefficient of x squared in that expansion is minus 15. So again, we look at the multiplications that can give us the power of x to be 2. So 2x times minus 80ax, this gives me minus 160ax squared, and then I can also use 4 and this guy, so 4 times 80, that's plus 320a squared x squared equals to minus 15x squared. You can factorize your x squared, so you have x squared into minus 160a plus 320 a squared equals to minus 15x squared. So x squared and x squared cancel. You have minus 160a plus 320 a squared equals minus 15. Eventually you have a quadratic formula, a quadratic equation rather, not formula, quadratic equation, minus 160a plus 15 equals 0, which you can solve using the quadratic formula, or you could factorize anyhow you want to do it. The purpose of this video is not to show a quadratic equation, how to solve them, so I'm just going to skip that step, but I'm sure you guys know how to do it. Using your quadratic formula or your calculator directly or factorization, you get a to be 3 over 8 or a to be 1 over 8. And if I go back to the question, it said find the possible values of a, so plural. That means it was expecting us to get more than just one answer, which we did. We got 2, 3 over 8 or 1 over 8. So those are the two answers for part A rather. Part B says it is given instead that in the expansion of 4 plus 2x and 2 minus x all raised to the power 5, the coefficient of x squared is k. It is also given that there is only one value of a which leads to this value of k. Find the values of k and a. So from part A, it's basically the same thing, they just changed the coefficient of x squared it was giving. In part A it was giving minus 15, in part B it's given k. So there's no need for us to do all this expansion again because it's just the same. It's just that from this part over here, it now turns into something like this. It becomes minus 160 ax squared plus 320a squared x squared is now equal to k x squared, because the coefficient of part B says the coefficient of x squared is now k. And again, doing our factorization, we have minus 160a plus 320a squared equals to kx squared. This and this cancel, so eventually rearranging everything, you get 320a squared minus 160a minus k equals 0. Now when you have anything like this, you have two unknowns in this equation, you have k and a, you can use your discriminant. So using discriminant, you have b squared minus 4ac is equal to 0, or b is minus 160 all squared minus 4 into 320 into minus k equals 0. Minus 160 all squared is 25600 minus 4 into minus 320k equals 0, and this becomes 1280k equals minus 25600, and k is minus 20. So if our k is minus 20, because it also asks us to find the value of a, it said find the values of k and a. So if my k is minus 20, I can just put this k back into this quadratic equation here. So we have 320a squared minus 160a minus 20 equals 0, and then you can use your quadratic formula or factorization to solve for a. Doing that, you only get one value of a, which is a is equal to 1 over 4. And that is the answer for that question. And on to the final example. There it is. This is a challenge question. So do have a try at this by yourself, and then you can pause the video to have a go at this by yourself, and then resume the video to see if you're correct or incorrect. If you are incorrect, please take note of your mistake. So let's go ahead. It's just 4 marks and just one part, but it's not, I won't say it's complicated, it's just that you have to have a slightly higher order of thinking when solving something like this. You need to find the coefficient of x in the expansion of x over 3 plus 9 over x squared all raised to power 7. Now directly it goes and says find the coefficient of x, but the problem here is, you know, for example, if I have something like 7 combination 0, or let's say 1 to begin with, a to power 6 bx to power 1. If I have something like this, I know that whenever I multiply this out, whatever I'm going to get, my coefficient, or rather my power of x, is always going to be x, because there is only just one x involved. But if I have something like, let's say, a over x over here, then suddenly the game changes, because now I have something like x to power 6, because eventually this is a to power 6 over x to power 6, and then, you know, this is being multiplied by bx, and if you're just looking at the powers of x, you would eventually have a to power 6x over x to power 6. Of course, you would also times this by 7 combination 1, but looking at the powers of x, this and this would cancel, so we would eventually have x raised to the power 5 as a denominator. So you can see it doesn't become as easy to find the coefficient of what you want, and that's the sort of scenario we are in over here as well. This question is asking us to find the coefficient of x. So we need to see which term, is it 7 combination 0, 7 combination 1, 7 combination 2, 7 combination 3, which one is going to give us the coefficient of x? And that's going to happen if my numerator of x, the power of my numerator of x, is going to be 1 greater than the power of my x in the denominator. So the reason I said you need a little bit of higher order of thinking is just you have to look ahead and see how it's going to work. It can take a bit of trial and error as well for some people, but there's no harm in it if you're getting the right answer. For example, if I take 7 combination 0, just concentrating on the powers of x for now. Forget about the calculation or the algebra, just focus on the power of x. If I do 7 combination 0, then I have x over 3 all raised to power 7 into 9 over x squared all to the power of 0. And all of this would give me x raised to power 7 eventually. So, and that's not what I want. I want x. I don't want x raised to power 7. So that doesn't work. If I do 7 combination 1, I would have x over 3 all raised to power 6 into 9 over x squared all raised to power 1. Eventually, my power of x from this guy would be x raised to power 6 all over, and then from this guy it's going to be x squared. This and this would cancel, and this would give me x raised to power 4, which is again not what I want. If I go ahead and check the next term, I have 7 combination 2 into x over 3 to power 5 into 9 over x squared all squared. So this guy again would give me x raised to power 5, and the denominator would give me x raised to the power 4. Why 4? Because the denominator is to the power of 2, and all of that is being squared again, and 2 squared is 4. This cancels this, and this gives me x raised to the power 1, which is simply x, and that is what we are trying to find. That's what the question is asking us, find the coefficient of x. Hence we use 7 combination 2. So you can see, before the question even starts, before your answering starts, you need to know which one to go ahead and start with first, and in this case it's 7 combination 2, because that's the only combination that's going to give us the power of x to be 1, which is x. So we have 7 combination 2 into x over 3 to the power 5 into 9 over x squared to the power 2. 7 combination 2 is 21, so you have 21 times x raised to the power 5 over 3 raised to the power 5 as well, because what happens to the numerator is also happening to the denominator, and 3 raised to the power 5 is 243, and multiply this out by 9 squared, that's 81 over x squared, and all squared that again, so that's x raised to the power 4. And you know this is over 1 as well, so 21 times x raised to the power 5 times 81, that's 1701 x raised to the power 5 all over 243 x raised to the power 4. And I think 243 does divide 1701, yes it does. This gives 7, this gives 1, and this becomes 1. So you have 7x, and the question asks us to find the coefficient of x. So the coefficient of x is simply 7, and that is the final answer for that question. And that indeed brings us to the end of this video as well. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Once again, thank you for watching. Have a nice one.